All right, so here we go again. It's supposed to simplify. Now, the key here again is we have to factor. So what we need to do is start on the numerator and factor that. So factors of 4 and 5 that add to 19. So I'm going to say let's use 4y and then y, and then let's put the 5 over here. We need a positive 19, so 4 times 5 is 20. So if we put a plus here and a minus 1 here, that gives us 4y squared plus 20y minus 1y, which is 19, minus 5. Now, the trick is if you get one of them factored easy, the other one's going to factor pretty easy too. So now we know 4y minus 1. So what I'm going to suggest is let's try 4y minus 1 as our first term because there's not a 5 here, so we can't say it's going to be y plus 5. And then what's their other term going to be? Well, 4 times what is going to be 12? Well, 4 times 3, so 3y. And then over here we have to have a 4, and we have to have a negative here, so that means this has to be plus. So now that's going to be a 12y squared plus 16y minus 3y, so that's 13y minus 4. So that's the factor form. Now we go back to, let's cancel. Well, 4y minus 1, 4y minus 1, again, works really nice. So that's our solution. So we get y minus 5 over 3y plus 4. All right. So one of those that it works out nicely. Whenever they give you something like this, usually one set of factors is going to cancel. So if you can do one of them easily, do it, and then the other one, see what would work or not work. And so it looks like, this one would work down here probably. The 5 won't work because we don't have a 5 here. And then just go ahead and do the factoring after that, and then it makes it a lot easier type of problem. All right, so here we're supposed to use this equation to complete this table. Then we're to determine any x value that will make the sketch or make the expression undefined. Then we're supposed to sketch a dashed vertical line, which is going to be our asymptote in the xy plane at any undefined values of x, and then plot the points from the table, and then sketch a graph of the equation. Do not let the graph cross the vertical dashed line. All right, so what we're going to do is we're going to plug in things, and due to kind of a lack of space here, maybe I could put it on the next page even, but let's just start plugging in values. So a minus 10, so it's going to be a minus 10 over, and that looks like 3. So a minus 10 thirds, minus 10 over a minus 3 is going to be a positive 10 thirds. Okay. Now we have a minus 9 over a minus 2. Minus 9 over minus 2 is going to give us a 9 over 2. The negatives cancel. Here we have a minus 8 over a minus 1, so that's just going to give us a positive 8. Now we have a minus 7 over 0. Ding, ding, ding. That's our undefined. So, I don't know, let's do undefined and just do an abbreviation. Now 0, well, 0 over 7 is still going to be 0. And we have 7 over 14, well, that's going to be a half. 8 over 15, well, we can't reduce that, so it's going to be 8 over 15. Now we have 9 over 16, it looks like. And then we'll have 10 over 17. Okay. So, determine the value that makes it undefined. Well, that's that one, so that's A. B, sketch a graph with a dashed line. All right, so we'll just make a crude graph here. And minus 7 is going to be right there. So that's x equals a minus 7. Okay. Now we're just going to plot points here. So 10 thirds is going to be up here on the top half, and at negative 10, that's roughly there. So that's a minus 3 and a third. So let's call that a 3 and a third. So that's going to be that point. Then at minus 9, that's going to be 4 and a half. So it's going to be a little higher. Again, it's just a sketch, so we're sketching. Minus 8 is going to be up here. It's going to be higher. Then 7's undefined. That's this point. Now, we don't have anything right after that. So let's also look at how about a minus 6? Well, minus 6 is going to be a minus 6 over a 1. So that's going to give us a minus 6. Oops. So we'll have that's our x, that's our y. And, oh, that's a 1. What am I doing here? Minus 6 over a 1, so that's going to be just a minus 6. Then if we have, let's say maybe do, I don't know, minus 3. Then if we plug in a minus 3, we'll get a 4 here. So minus 3/4 is going to be that one. So that's going to be for minus 6, we get a negative 3/4. Okay. Or minus, yeah, not minus 6. I looked at the wrong one. Minus 3, we get a minus 3/4. All right, so now that gives us some points closer over here. So then a minus 6 was a minus 6. And again, we're just sketching, so we're not worried about being exact here. Then a minus 3, which is probably about half that, is going to be just down a little bit. And then we had 0 is 0. 7 was a half, so we go all the way out here to half. And then it's just going up a little bit more at 8, a little bit more at 9, and a little bit more at 10. So it looks like the graph is going to do something like that and something like that. Okay. So we've plotted the points, we've sketched the graph of the equation, and again, we only get close to, we're getting infinitely close to that dashed line, but we're not actually ever going to touch it. Now, let's go over and see what this looks like on a calculator. So on a calculator, what we're going to do is we're going to say, okay, y equals, and we had x divided by x plus 7. Okay. And the window, okay, that looks like it should work. So that's what it is. Now, it doesn't put in this minus 7 vertical line, but that's what it's doing. And that's pretty much what we had too. We went higher up at 8, and then we went down, and it was just going to go slowly down and down and down. This one went up, and it's just slowly getting bigger that direction. So our graphs match, and so that's a good thing. So let's go back to our thing. And so again, that one keeps going down, this one's going up. So it looks like we've done a good job on this one. All right, so let's stop there and come back for some more.